All right, let's do the review for the inequalities test that's coming up. We are graphing the inequalities below, and the first three are given to us in the slope-intercept form, where y is already by itself. So y greater than 2x minus 5, we should be able to just use our y-intercept of negative 5. 1, 2, 3, 4. Oopsie. 5 is my first one, and my slope is 2, so I go up 2 and over 1. I continue to do that. Um, Now, what I'm noticing is that I can draw my line at this point, and the line that I'm going to choose to draw, I'm going to make it, go ahead and just make it a dotted line. And because it is just a greater than. So if I go ahead and draw my line, I'll have to send it here. So we've got a line here. And then we need to determine where we're going to shade. Well, y is greater than, so that means those values are going to be above this line. And so above is going to come this way. We can fill all of that in. Does not include the line for a solution set. So if I had to come up with solutions, 0, 0 is a good one. 1, 1, 1, 15, negative 2, 3, all of those would be good solutions in there. All right, the next one, we have y is greater than or equal to 1/3 x plus 2. So we'll start at the 2, and we have 1/3, so I'm going to go up 1 and over 3. I'll do that a couple times, and then I can draw my line. Now I know this for this one, I need a solid line. So I'm just going to, well, I shouldn't have done that, but we're just going to do a solid line here. Got the arrows as well, and I can extend this to, whoops, extending the wrong thing. Extend this to go through all of them, and I think we moved the whole paper, didn't we? Yes. Fix that. Okay. And it is a greater than, so that means it is going to be shaded above as well. So we will go ahead and shade all of that above the area. Okay. All right. Next one, y is less than 6. Well, y is less than 6. We just need to go up to 6. 1, 2, 3, 4, 5, 6. Down up there. And less than 6 means that it's just going to be a horizontal line. It's a dotted line, so I'm just going to draw it by hand since I'm here. So it's less than 6, and we're going to shade then below. Because of less than means that it's going to be all these things that are below this value. Okay? Yes, all of this part should be shaded. So a solution could be like, again, 0, 0. As long as y is less than 6, we're good. We could have negative 482 and 2. We're good. Okay? So the next ones, we have to get y by itself in order to graph these. It makes it so much easier. So the first thing I'm going to do, get rid of my x, so I'd have negative y is greater than negative 5x plus 6. And then here's the deal. I basically need to divide everything by negative 1 because there's a negative sign in front. So to make that positive, I divide by negative 1, and when that happens, I flip my sign. And I have 5x and minus 6 on this case. When I go to do that to graph, I'd start out at negative 6. And my slope is 5, so I'm going to go up 5 and over 1. This one's going to be really steep. The type of line I'm going to have is going to be a dotted line because of the fact that it is greater than or less than, excuse me. And then when I go to shade, I need to be lower than, below the line. So I look here, and these are those values that are less than. So this would be considered below the line here. That would be our solution set. Now this time we can't choose values that are on the line because of the just being less than. All right, for the next one, I need to solve for y again. So I'll subtract 3x. And so I have 9y is greater than or equal to negative 3x. I could put plus 0, but that'd be kind of silly, so I'm not going to do that. Divide by 9 on both sides, so y is going to be greater than or equal to negative 1/3 x, because I can simplify the 3/9. I don't have to switch my sign because of the fact that it is, I didn't divide by a negative. So in this case, I have my y-intercept's at 0, and my slope is negative 1/3. My line is going to be a solid line in this case. Oh, that's going to be dotted. We don't want dotted. So, get rid of that possibly. Creating a line, and we'll make it solid instead. Adjust that. Goes through. And then I'm greater than or equal to, so if I look here, I know that I need to be above this line to be greater than or equal to. So yes, I would be shading up above. All right, and then this one for part C, again, I need to solve for y. I have negative 2y less than or equal to negative 4x plus 8. I'm going to divide by the negative 2. Since I'm dividing by a negative, I know I have to flip the sign. I'm running out of room, so pretend I'm dividing by negative 2 to get a y, divide by negative 2 to get a positive 2x, divide by negative 2 to get a negative 4. So to graph this one, we're going to start here at negative 4. My slope is 2. My it's not going on there very well, is it? My line is going to be solid because of the fact that it is a greater than or equal to. So we will see if we can do that part of it. We didn't have a line thing. Well, that'll work. And greater than or equal to puts us above. So if I look here, these are the values that are above. So we're going to shade on this side. All right. Should be pretty good to go with that. If you can graph a line, and if nothing else, if you're not sure, plug in a point. Plug in 0, 0, see if it makes it true. All right, number 3. In order for a student to be considered for a certain college grant, the combined income, so combined income, that makes me think, oh, we're going to add that together. The student's parents must be no more than $35,000. No more than $35,000. If F is the father's income and M is the mother's income, which inequality represents the conditions of the grant? Well, combined income of mother and father is going to be like F plus M. That would be how we would get the combined income. You add it together. Has to be no more than $35,000. That means it can be $30,000, but it can't be $40,000. So that means this value has to be less than or equal to, because it can equal the $35,000, but that would be the maximum value that it could be. So our inequality would look like that. All right, so number 4, Mike sells used cars and he makes $250 per week plus $200 for each car he sells. Because of Mike's cost of living, he needs to earn at least $1,250. So he has to earn at least $1,250. And doing that, he's getting $250 a week plus the $200 for each car. How many cars must he sell each week to accomplish this? Write an inequality and solve to find your answer. So he does make the $250 each week. And keep in mind, we're saying each week here. So we're just going to have it one time, $250 plus, because it tells us the plus, $200 for each car. Well, we don't know how many cars. That's our X, because we want to figure out how many cars must he sell. So X equals number of cars. Okay, so I could have used a C instead. That might have been easier. And that has to be greater than or equal to that $1,250 so that he can pay his bills. It's only $1,000. He can't pay his bills. He needs at least $1,250. So if we go to solve, I'd subtract 250 from both sides and have 200x is greater than or equal to 1,000. And then if I use my calculator and take 1,000 divided by 200, x has to be greater than or equal to 5. So he has to sell at least 5 cars in order to pay his bills. All right, a local electronics store. CDs cost $7 and DVDs cost $20. Write an inequality to describe the number of CDs X and DVDs Y that can be purchased for $75 or less. So you have $75 to spend. That's your maximum. That means everything has to be, when I go out of the store, less than or equal to that $75. Now, CDs cost $7. So if I buy 3 of them, that's $21. And I got that by taking 7 times however many CDs we have, because this is telling us the number of CDs and the number of DVDs. If I buy DVDs as well, they cost me $20 each. So 20 times 2, if I buy 2 of them, would be 40. But here's the thing. So I just take 20 times Y, whichever it is, to get up with that. So here would be my inequality. The 7x plus 20y has to be less than or equal to 75. Not solving, just setting up. Create an inequality that meets the following conditions. So I have these solutions. These are solutions. So 3, 7, 1, 2, 3, 4, 5, 6, 7. 8, negative 1. So that one is, and negative 4, 6. Yeah. So those are all solutions. So that means it's got to be shaded up on that side, looks like. Non-solutions, so the ones that aren't going to work are like negative 7, 3, 1, 2, 3. So that one doesn't work. And then 2, negative 1, 2, 3, 4, 5, 6, 7, 8. That doesn't work. Okay, so here's the thing. Basically, I can draw a line here that kind of separates my solutions from the non-solutions. Now, your line may look different than my line, but it could be dotted, it could be solid, it could be a little bit steeper, not quite as steep, as long as it separates the solutions from the other. My y-intercept, if I look here, is 1, maybe, if I can do. So my y-intercept is 1, just kind of seeming to be moving. See, and keep in mind that I could, if I needed to move this various places, I could move it here, I could come down here, but I'm going to leave it to where my y-intercept is 1. So I know that I've got, I know why I'm not writing, so I know I've got a plus 1 here once I move that back. Okay, my slope looks like I'm going from here down 2 and over 3 to get to my next one. So negative 2/3 x is going to be my slope. Kind of don't have room there. So my y, I need the y there. I have my negative 2/3 x plus 1 for my line. Your line might look different as long as it meets the conditions. And being that I'm shading up here on this side of it, I know that that's above, so it's got to be greater than. So when I go to do that, it should be greater than. The way my line is, since it's solid, I'm choosing greater than or equal to. If you were to draw a dotted line, it would have to be just greater than. All right, I'm about to run out of time, so I'm going to just kind of circle these real quick. I plug these in. If I plug these in, that's not true, but this one is. If I plug this one in, the 12, negative 12, it's not true. But if I plug in 15, negative 3, it is. All right, I got 30 more seconds here. So if I plug them in, I know that the first one, oh my goodness, what just happened? The first one is true. So 215 is a solution. If I plug in 0, 1, it equals. So because it would be